All right, so we got the law of cosines here. But how do we get the formula? So this is derivation of the law of cosines formula, which has a form c squared equals b squared plus a squared minus 2ab times cosine big C, right? And so these letters are arbitrary, but they represent some triangle ABC. Sorry, a little editing issue there. But how do we get here? So here's my triangle right here, ABC. I drew an altitude from C to D and labeled that H. That'd be the height of this triangle from C to D. And that splits ABC into two triangles, triangle 1 and triangle 2 in Roman numerals here. And then we have a side length for triangle 1 of X, and then a side length for triangle 2, C minus X. It's going to be the difference between C and this X right here. So for triangle 1, if I write the Pythagorean theorem to kind of just orient ourselves with the triangle, I have b squared, which is the hypotenuse, equals h squared plus x squared. And this is a relationship within this triangle because it's a right triangle. Now I'm going to solve for h. I'm going to do that by subtracting x from both sides. And I have b squared minus x squared equals h squared. And this will become important in just a moment. So I'm going to do the same thing for triangle number 2. I'm just going to start up here. So what's the Pythagorean theorem relationship to the sides for triangle 2? Well, I have a squared, which is a hypotenuse over there, equals c minus x squared, okay, plus h squared. So I'm going to do two things here. One, you notice we have an h squared here, and we had an h squared in triangle number 1. And I have some way to replace h and get rid of it because I want my formula to end up here, just be in terms of triangle ABC. So I'm going to rewrite the Pythagorean theorem formula for triangle number 2 as a squared equals c squared minus 2 times c times x plus x squared. Now I'm going to add h squared, but I'm going to substitute b squared minus x squared. And you'll see right away that I have a plus x squared and a minus x squared. Those go away. So now I have a squared equals c squared minus 2 times cx plus b squared. Now this is just how the parts of these triangles are related to one another, okay? Now I have this variable here, x, and I want my final formula to be in terms of just a's, b's, and c's, okay? So how do I solve for x using triangle number 1? This time I'm going to do it in blue. I can use a trig function. I'm going to use cosine of a. And I'm going to choose cosine because it gives me this x right here because that's adjacent. I'm going to divide it by the hypotenuse because cosine is adjacent over hypotenuse. Solving for x, multiply both sides by b, and I get b times cosine a equals x. And there's my x. So I'm going to rewrite this formula here as a squared equals c squared minus 2c times b times cosine a. I'm going to simplify this and write it in a way that's more easily understood. Oops, and then plus b squared. My apologies. I left that one out. So a squared equals b squared plus c squared minus 2 times b times c times cosine a. And now I have relationships in just terms of a, b, c, right? A, b, c's, okay, which can help me find the relationship for parts of just a general triangle. So this is helpful in certain circumstances and useful for right triangles and non-right triangles. And we're going to get plenty of practice with this, I'm sure. Thanks for watching.